Alright guys, we're solving the last couple of problems from the exam. This is going to be the fourth problem. We solved part 1, or part I, on the last video, and now we're going to be turning to parts II and III. Part II says if the objective function coefficient, or the objective coefficient for S2, the second non-basic variable, changes, i.e. the second coefficient in C sub n, determine the range for which it can change and the current basis remain optimal. Finally, it says you can give your answers in terms of a delta or C sub S2, or the subjective function coefficient for S2. Okay, so this is a question on sensitivity analysis, and if you studied your review sheet, you saw that if you change Cn, or the objective function coefficients of non-basic variables, to check for optimality, all we need to do is make sure our reduced costs of our non-basic variables remain unattractive. Okay, so to check for optimality, let me say C that CB B inverse n minus Cn, which those are our reduced costs for our non-basic variables. I'll just say remain unattractive. Okay, and specifically that means that if it was a maximized problem, we'd have them non-positive, and if they were a minimized problem, non-negative. I'm sorry, just backwards of what I just said. If it was a maximized problem, we want the reduced costs of the non-basic variables to be non-negative, just what I wrote, and if it was a minimized problem, they would need to be non-positive. Okay, so that's what we're checking. In the information given in the problem, let me go back to here, we see everything we need to compute the reduced costs. In other words, here's C sub B, here's B inverse, here's n, and here's C sub n. Okay, so to compute the reduced costs, all we need to do is write those components out. So first C sub B, then B inverse, B inverse was like that. And then in this problem, n and C sub n were pretty convenient. Just the identity matrix and 0. Okay, so that was C sub B, B inverse n minus C sub n. Okay, and actually the information provided computed all that out for you. Okay, that was right here. Okay, so C sub B, B inverse n minus C n is equal to 1.167 and 0.333. Okay, so you know, if you understood that, you've got probably most of the problem done. The only thing left to really do is to understand when I say we're changing the objective function coefficient of the second non-basic variable, or S2, what coefficient or what parameter in this sort of function are we changing? Okay, and if you understand what the problem is asking, you understand that this is the parameter we're changing. This is C sub n. This is the objective function coefficients of the non-basic variables, and the problem explicitly stated we're changing the coefficient of the second non-basic variable here, or the second slag variable. Okay, so really what's going on is what we want to do is compute the same exact function, almost, negative 0.167, 0.667, 1001, and now we can add our delta to the parameter we're interested in doing a sensitivity analysis for. Okay, and it was kind of convenient, I guess, the way this problem was given. Since this is just 0, I mean adding delta there, all you need to do is we're going to be subtracting a positive delta, so you can quickly just see what that's going to end up being. Everything's going to be the same except in this second term, the second reduced cost, in other words, it's going to be a minus delta.